One of the main challenges in current blockchain technology is in finding the right balance between security, decentralization, and scalability. And we in our research team have designed ELVES, which is a scaling solution that drastically reduces the computing power while maintaining a high level of security. My name is Chen-Da. I'm a research scientist at Web3 Foundation, which is a team that focuses on pushing the frontiers of blockchain technology in topics like cryptography, distributed systems, and economics. When you think about a blockchain protocol, you usually have this set of nodes, let's say 1,000 nodes, and we rely on the fact that a majority of the nodes are behaving correctly. So we want security of the blockchain, even if, let's say, 30% of the nodes go down or are hacked or something like that. All these 1,000 nodes check the block, and then you take some sort of majority decision. Of course, this is not really scalable, because if for every block everyone is checking, then this becomes inefficient very fast. You select a random subset of the nodes. This is called sharding, or selecting a committee. And then this committee essentially does the same as before. You require that this subset of parties has this 70% of honest nodes, and then you do exactly the same protocol as before. But the problem of this approach is that ensuring that this random subset of parties contain 70% of honest nodes requires the subset to actually be pretty large. If you compute it concretely, then you require, let's say, 500 nodes for this random subset. And ELVES is actually a protocol that does this much better. You don't need 500 nodes to check the block. We start from a very, very small subset of nodes, and then we add more and more nodes. But in expectation, we have around 80 nodes, and we rely on economic security. This means that the setting of ELVES is a little bit different. Let's say that the nodes put down some collateral, some skin in the game, to say so. And if something goes wrong or they are caught cheating, then they actually lose this deposit money. Even if the adversary controls 1/3 of the nodes, it's not worth it for the adversary, economically speaking, to misbehave. Computing power that we save, it's pretty big. The protocol has been deployed in Polkadot and Kusama for a few years already. And recently we have written a paper where we proved that the protocol is secure, and we computed the explicit parameters to achieve this security.